take it over, Miss Ashley Harding. Have a great one.
Hi, thank you so much, Jack. And everybody, welcome to OK Google Tell Me How. And welcome to our special edition, OK Kelsey Tell Me How, where we have the man, the myth, the legend, Kelsey Hightower himself, talking with us about all things Kubernetes. Jack, if you go to the next slide. Perfect. As always, guys, thank you so much for the love on our YouTube live channel. If you'd like to subscribe, please look at the link below, as well as look for us on YouTube Live. We stream our webinars every Thursday, and we have a channel for you to subscribe to. So don't fret if you miss out on Thursday at 1 p.m. You can go back to that YouTube Live link and watch our recordings. Awesome. So a little sneak peek of what's coming up next week. So next week, we have our friends from Chronicle talking about how to apply cybersecurity best practices to ensure you and your users are staying safe. Should be a really good interactive demo and presentation on Chronicle and how we're helping our customers with their cybersecurity needs. The week after that, we will have our special guest, Alan Ranciato, member of our Google team, talking about how to optimize costs in Google Cloud. I'll be posting in the chat our landing page, so you guys can go ahead and register for those events as well. As always, it'll be super interactive, so come with your questions and your lunch. And a little bit of housekeeping before we get started. So everybody, please mute yourselves. I know some of you guys bring your lunches and have a lot of questions you want to ask, but please mute and I will get to your questions through the chat. Or if you'd like to chime in, just ping me on the chat as well, and I can open it up for questioning, which leads us to our questions. Please just wait. If you are feeling a little shy and would like me to ask your questions, just post them right there in the chat and I will find a break to ask Kelsey the questions, or we can wait until the live Q&A portion. Another thing to keep in mind is to please check in. So we are also streaming this on YouTube Live. So everyone that is watching right now, please check in if you'd like to receive to be in our random drawing to receive a free Google Home Mini. I know I love mine and have to unplug mine each week on Thursdays at 1 p.m. because it likes to join in. So it should be a really fun prize. So everyone please check in. And then lastly, our survey, we'd love to know how you guys think we're doing. So please post in our survey what you like about our webinar, as well as things you'd like to see. Also, sounds like someone is breaking rule number 1. Please mute so everyone can hear Kelsey when the content begins. But thank you so much. And now here comes the main event. I'd like to introduce our speaker. So our speaker this week is Kelsey Hightower, Kubernetes guru here at Google, open source advocate, Google developer advocate, and keynote speaker at KubeCon. You may also know him as one of the authors of Kubernetes Up and Running, Dive into the Future of Infrastructure. So Kelsey, thank you so much for coming to join us today. We really appreciate it. Oh, looks like you're on mute, Kelsey.
Awesome. Happy to be here. I love that photo. Looks like I'm winning something. I'm not quite sure what I won, but I definitely look like I'm winning in that particular photo.
Yes, definitely. So for those who have tuned in each week on OK Google Tell Me How, you all know in order for our speakers to begin, they have to answer our icebreaker question. So Kelsey, you know, you're a Kubernetes personality, you've been speakers at KubeCon, and you have almost 100,000 followers on Twitter, which leads me to think your next big move should be your own TV show. That being said, Kelsey, if you had a TV show, what would you call it and who would be your celebrity co-host?
Oh, wow. So there's, I used to watch the MTV series where, they would take your old car and, add rims to it and put dice in the mirrors, paint it a crazy color that you would never drive to work in a professional setting. And it was Bleep My Ride. And if I were to do my own show, I would definitely be, I don't think I would have a co-host. I would probably mimic that style. And what I would do is I would take over people's infrastructure, right? So I would work with your system administrators or your DevOps team, get access to the infrastructure, and I'll just start adding random projects from the CNCF, right? Throw some Prometheus in there. I'm talking about stuff you don't even need. I'm just going to install everything so you can be as cloud native as all the other presenters. You'll never have envy of them again. And then at your all hands, I would reveal all the changes I've made to your infrastructure. So no guarantees that it's going to work, but you will have the dopest infrastructure ever, and your resume is going to be amazing once I'm done with it.
Amazing. Are you going to dub over X's music as well and just say, Kelsey gonna give you
Yeah,
infrastructure?
we'll just have backgrounds of pagers going off, right? We'll have enough incidents in production that we won't even need a soundtrack.
Amazing. Thank you so much. Well, guys, with no further ado, I'm going to let Kelsey take it over.
Yeah, so there's a lot of stuff I could show you, right? So there's demos, and demos is kind of my forte, but I think a lot of people have a lot of questions. And what I've seen is we never get to the good part. Like the Q&A is always the good part in these things. So I do have my screen. I'll share my screen when necessary, but I'm going to start with some of the questions because I know a lot of people are going to have a bunch of questions. And I noticed that there's a lot more people with experience with a lot of these technologies over the last 5 years. This stuff is so accessible. What we do see though is like people just tripping up over, similar stumbling blocks. So let's see if we can actually solve some of those. So we got a few questions from, I think a few people attending ahead of time. Also, as a reminder, you can throw your question in chat. I have my eye on it as well. And so is the Google team here. So we're going to start with some of the Q&A. And one of the questions I got was, Kubernetes is an interesting platform because how it helped move appropriate application workloads towards containerization by providing orchestration without lock-in, right? So there's that lock-in. Everyone's so scared of lock-in. So you don't get locked into a physical infrastructure, right? So the idea here is that, if you use Kubernetes and you kind of adhere to some of the Kubernetes principles, then you're going to worry less about bare metal versus VMs or GCP versus another cloud provider, right? You're going to start targeting Kubernetes. And the second part of this question is like, however, what are the biggest trade-offs which such a move puts an organization at risk, right? So nothing is for free. If you go all in on Kubernetes, what trade-off are you actually making? And this is one area where I don't see a lot of people write down the trade-offs, because if you don't write down the trade-offs, then you're not going to be able to make some of those tough decisions when the rubber meets the road. And the last piece of this is, how should a business be looking to prepare in order to reap the benefits while lessening the exposure? All right, so yes, you're going to trade off one set of APIs. So if you're using something like VMware today, you probably built a bunch of tools around VMware. Maybe you're using something like Terraform to help you with your VMware install. And then that's going to be the area where, if you want to use a lack of a better word, lock-in occurs. And the same is true for any IaaS platform, right? Whatever their command line tools are, CloudFormation, you have to pick something, or you get locked into yourself, right? Like raise your hand if you got a bunch of bash scripts in your home directory doing God knows what, right? Then that's your API and that's your interface. So in the Kubernetes world, the trade-off is Kubernetes has an opinionated networking model, right? All pods are reachable. Typically the subnets, the IP address ranges that we give to Kubernetes should be typically hidden from everything else outside of the cluster, right? That's the trade-off that you make. So here's what happens. Most companies look at Kubernetes networking model and say, I could care less. I'm going to recreate my enterprise IT's definition of networking inside of Kubernetes. And we watch people spend, 6 months recreating and breaking, salvaging Kubernetes networking model in favor of the one that they already have. Now, there are good reasons to do that, but the drawback is now you're back into the world where you may not have the flexibility. You may not have that dynamic infrastructure where all the other tools above Kubernetes assumes you have, right? So since you've kind of broken that model, and the way I like to think about this is some people say, hey, Kelsey, help me make the new thing work the old way. And instead of getting any value out of Kubernetes, they spend their time making it look like what they currently have and saying, wow, this thing isn't a game changer. It's like, yeah, of course it's not, right? Like you took all the game-changing features away over time, right? So you got to find some balance there. So I think the thing is, if you're going to go into the Kubernetes world, jot down the things that you're going to trade off. You're going to give up some control in favor of Kubernetes opinions. But what you'll also find is that maybe 85% of what you're already doing will translate to Kubernetes. You're just running your binaries on Linux still, but just through a different mechanism. And if you blend those two well, I think you're going to do a good job. Now, there's like a question that's kind of related here. Like I worked on PCF, and this is right here inside of the chat. I worked on PCF. How easy is it to move to Kubernetes migration strategy? So let's be very specific here. If you're using PCF, congratulations, you've taken a big step towards decoupling your app from the machine, right? A lot of people like to have a comparison, PCF versus Kubernetes. And you could definitely do that, but it's kind of unnecessary. So to me, Kubernetes is one layer below Pivotal Cloud Foundry for people unfamiliar with what PCF means. And Kubernetes is kind of this layer around, let's take a bunch of machines and then abstract them away. And Kubernetes kind of goes a bit step further. It knows how to integrate with things like load balancers and storage and secrets and config maps. And it can be extended to support new things, right? So when you start to think about Kubernetes, it's probably, and you see the Pivotal team doing this already, including the VMware, now that they're back at VMware, they're starting to move PCF to be rebased on top of Kubernetes, right? So the question now is like, why are they doing that? And it's because of all the things I mentioned. Kubernetes is just a much better platform for distributed system than every PaaS out there rolling their own. So now you start to think of, all right, what do I give up if I migrate away from PCF to a pure Kubernetes? I think the things that most people talk about is even more opinionation on how apps should be built and deployed, right? So in the PCF world, you're going to have build packs and, especially if you're writing Java, there's going to be a lot of integration with things like Spring Boot and all of these things. And then there's going to be things like CF push, right? So this idea that, hey, this is the basic developer workflow I'm going to use to push stuff in and out of PCF. Now, PCF is not without its trade-offs though, right? Once you start getting out of that 12-factor area, you start trying to run things like a big old JBoss app. You start needing local file storage or et cetera, et cetera. Now you're starting to find yourself in a weird world where it's like, oh, now I need a second system to run all the stuff that I don't have time to rewrite or modernize. And that's where you start to say, well, maybe Kubernetes is just enough. And I think some people are seeing that. And the last thing here is what a lot of people will do is say in PCF, if you move to containers instead of like CF push and build packs, you're kind of now in a more portable workload, right? Just getting to the container image as an artifact, even while you're in PCF land, sets the stage for you to then go look at GKE, Cloud Run, which is our serverless offering optimized for containers. Or you can actually just take those same PCF containers and just run them in open source Kubernetes. So a lot of people, their first step would be get to a more platform agnostic packaging format. Then that opens up the door. So then in workflow, if you really like the PCF workflow, I would encourage everyone to look at KF. So KF is basically Kubernetes or PCF kind of feel, Cloud Foundry workflow for Kubernetes. I'm going to share my screen real quick and we can poke around over here a little bit. So let's see if I can share my screen. Let's see here, present now. I'll share my entire screen and we'll do this. Okay. I'm assuming people can see my screen here. So I'm right here on GitHub. It's an open source project. A lot of the Googlers work on this, and a lot of these Googlers actually contribute to Cloud Foundry. We don't really have a big war between Cloud Foundry or Kubernetes. It's more like we know that Cloud Foundry offers value. We have a lot of people who used to work at Pivotal, worked on Cloud Foundry. They understand the value of giving developers an opinionated workflow. So what they've done is they built this KF tool, and underneath it, they have basically, I wish I can find some of the videos. I think they archived it and moved it to another Cloud Foundry repo. But basically what they've done is there's a KF tool that lets you do some of the same CF push workflows, and then you end up with Kubernetes objects underneath. So if you really think you need that particular workflow, check out this project or even the stuff that I think Pivotal's picking up in its place to get that same experience, but not giving up the flexibility of Kubernetes. That's a good question, by the way. I'll stop there for a second. If anyone has a live question as a follow-up to any of the two things I just covered, I say jump on now, or I'll move to the next question. I'll give people a few seconds. That's a few seconds. So I'm going to go to the next question in the chat, and then I'll return to the pre-baked questions here.
And
So
Kelsey, based off that one question, I would love if you could also expand on AWS's version as well. If we're going to talk Microsoft, might as well bring up the other elephant in the room as well.
yeah, so let's go through this, right? So I actually spend quite a bit of time just to remain authentic, right? The last thing I want to do is show up to a fellow engineer or one of our potential customers and say GKE is better than AKS, which is Azure's Kubernetes offering, or EKS, which is Amazon's Kubernetes offering. And there's others out there from the various cloud providers, but those are the big two players, right? And one way I do that is I just do some basic things, right? So I know Kubernetes pretty well. So really what I'm talking about is what is the managed experience for the Kubernetes offering. So we'll start with Azure and then we'll go down to AWS. So Azure, you're in luck, right? One of the founders of Kubernetes, Brendan Burns, works at Microsoft. This was a great move years ago because one of the promises of Kubernetes was it was going to work anywhere. In order for that to be true, it actually needs to be everywhere, right? So there you go. So the next thing is, what's their offering look like? So in the GKE world, we manage the control plane for you. It's kind of in a Google specific project. It's out of the way. You don't actually see it. And then you just manage your nodes. And we had this concept of node pools. And one thing Google did that was really interesting, we started changing GCP itself years ago, right? So what that means is, I'm going to share my screen again here because it's really important to understand the differences. There's a situation where in the AKS Azure case, they do a really good job of installing Kubernetes across a set of VMs and integrating other Azure services like their load balancers and IAM. They do a good job of that. I don't want to say anything bad about their integration efforts, and they have the expertise to do it. The difference, though, is one of philosophy and commitment. If you look at my screen here, you'll notice this is like the GKE UI. And it's a first-class citizen inside of the GCP platform, right? So it's not just like, oh, we install Kubernetes for you, and here's the open source dashboard. Have fun with that. While you could use the open source dashboard, most of our customers elect not to because there's a bit more power here, right? So for example, a couple of things. I can register external clusters into what we call the GKE hub. So if you notice, there's a lot of our on-prem efforts to take GKE under the Anthos brand on-prem. But what that means is you can start to aggregate clusters, even ones in AKS, if you install the GKE Connect agent. Once your cluster is registered, of course, we do this by default for all GKE clusters that you create either via the command line or through our UI here. The first thing you'll notice, though, when you create a cluster inside of GKE, that cluster is going to take about 5 to 7 minutes, control plane, the whole nine, and your cluster will be ready, right? So we have a bunch of these kind of cluster profiles, these wizards, or you can just use the command line like I do. But when you're done, you're going to end up with a cluster in about 5 to 7 minutes. The last time I checked on AKS, maybe 2 months ago, it probably took about 20, 22 minutes to get the full cluster. Now, you would ask yourself, like, who cares? 22 minutes is nothing, but it's a problem when you start to have lots of clusters, or like what many of our customers do, they will create clusters on demand. So let's say you have a batch job where you're going to use Kubernetes, and you want to take advantage of things like preemptible instances, or you only want to run that cluster specifically for that batch job. Maybe there's going to be a set of data that you don't want in your general Kubernetes cluster, or you're going to be taking advantage of things like GPUs that are only available in a specific region. When that happens, sometimes it's just easier to create a brand new cluster for that workload, do all your jobs, and maybe in a few hours, delete the entire cluster while you leave your steady clusters alone, right? So that becomes a big deciding factor when people can create ephemeral clusters and bring them in and out, and then take advantage of some of the other things around cost optimizations and so forth. Once you have a cluster, so here's another thing, and I think they just added it to Azure recently. We had this concept of a node port. So I'm clicking on one of my clusters that I'm running my Istio control plane under. And what you're going to see here is this is the GKE API. And what the GKE API does, it just gives you a really great cluster management API where you can manage things like your node pools. I'm going to try to make this a little bit bigger for people viewing. They manage things like your node pools. We have a dedicated node pool API. So let's say you do have a single cluster and you really want to mix your workload types. Well, this gives you the opportunity to, not only manage things like upgrades in the Kubernetes versions, we also have things like release channels, just like Chrome. So for customers that want to stick to more of a stable version of Kubernetes, maybe they lock in at 114 or 115 or 116. And then there's going to be other channels where we move updates a bit faster to stay closer to upstream. So now that you have the ability to have these channels, what we see our customers doing now is they can have a canary cluster that's doing rapid auto updates, staying up to date, and then modifying their configs if they see if anything breaks. Being able to do this separately means that you can attach and detach these node pools on demand using the GKE API and things like auto repair and auto upgrades, right? So I think AKS has some of these features, but it took them a long time to do things like node pools, right? That was just something that was missing. So you have to create your cluster, but you really couldn't change the shape of those particular containers. The next thing is things like the ability to browse all of your objects. So we've done a lot of work around CRDs. Shout out to Brendan. He's over at Microsoft. This was kind of some of his pivotal work. But Google has actually doubled down on Kubernetes API objects. And so what that means is we have a concept called KCC. So Kubernetes Config Connector. Let me look for it really quickly. And what you get with the Kubernetes Config Connector is this concept of we want to have every Google resource be able to be described using a custom resource definition. So for those that are new to Kubernetes, what that means is, let's say you want a Redis database, or you want a Cloud SQL instance, or maybe just a message queue. The goal is we should be able to do something like this. For example, this is a BigQuery dataset object. And ideally what you can do is you can craft one of these policies or one of these Kubernetes configs, give it to the Google API, or if you're running the control plane in your cluster, and then we would actually treat these resources like Kubernetes resources and create them in the background. So even the rest of GCP outside of core Kubernetes is moving towards a world where we'll have a parallel set of APIs. So you can always use the gcloud command line tool, the gRPC or REST APIs, but you'll also have the option of expressing all of your resources via this kind of Kubernetes model. And that's important because even our security is starting to adopt some of these other open concepts like open policy agent or Ragos config language. So this is something like being able to express policies across all of your config, regardless if it's Kubernetes or a VM. Once we standardize on this kind of API boundary, then we can bring in things like open policy agent, where people can then craft things using emission controllers to give fine-grained access to these various resources. And then we are basically making sure that you'll be able to browse all of these resources and get deeper into management there. And the last thing I'm going to show you here is that when we deploy apps into our particular clusters, let me go back here. When we deploy apps into our particular cluster, all of the node integration, application integration, all the workloads just have a very deep first-class integration to GCP as a whole. And we've also changed the way VMs work. We changed the way networking works, all in support of Kubernetes kind of being that future first-class component. So AKS gets very close. They both do fully managed control plane and node groups. But GCP has gone all in and changed GCP itself, whether it's a different resource for creating pub/sub queues, or how our machine types are laid out and our networking is laid out in support of Kubernetes, okay? So speed, performance, deeper integrations, that kind of thing. It's just a first-class, mature citizen in GCP. Now, the last thing, let's talk about Amazon's offering, right? So AWS has an offering called EKS. And EKS, to be fair, right, they are kind of like one leg in, one leg out, right? Because they have ECS, which is their first attempt at building this like container platform. And then they have Fargate, which is kind of a subset of the Kubernetes API. So Fargate for EKS is basically a subset of the Kubernetes API. For example, you can't run daemon sets, and maybe some tools from the ecosystem may not run there, because they made some trade-offs to give you more of a serverless Kubernetes. If you're going to compare GKE to something Amazon offers, EKS won't be a good match because they only provision the control plane, and then you have to go and provision the nodes yourself. Now, some people may like that, right? You can go and get Terraform and or you can go get some third-party EKS CTL from Weaveworks and manage your node pools yourself. But what you end up doing is that you just don't have this kind of unified UI and experience and API around what a cluster is. It's the control plane plus the node. So when we do upgrades, we upgrade not just the control plane, we do rolling upgrades of the nodes itself. So for a lot of our users of GKE, they express feedback that it feels more like Fargate, right? Even though you can see the cluster nodes here, we have things like auto scalers where a lot of customers just don't touch the nodes or even log into the nodes because they do everything through the GKE APIs. So if you want to compare with AWS, EKS is only going to meet you maybe a little less than halfway. And you have to look more at Fargate, but then you're kind of trading off more of that Kubernetes open ecosystem experience, right? So hopefully that answers a lot of the questions there, but it does come up quite a bit. How do you compare the two? And the last thing I will say this, you're an engineer. Forget what I'm saying. Forget what blog posts are saying. Literally click on each offering and see how long it takes before you start to be able to use kubectl to do things. And then I want you to go and upgrade those clusters. And you'll just fill it with your hands and say, okay, now I understand the difference. And it's honestly because Google has gone all in. We made a big bet. So imagine if Kubernetes didn't work out, we'll be looking really silly right now. But Kubernetes worked out. So we get to reap some of those benefits, and so do you if you're a customer. I know that was a long-ass answer, but you didn't come here for any marketing stuff. So I just want to make sure you have all of the details, you know? All right, so there's a follow-up question here. But PCF, I feel like it has easy UI, but Kubernetes is a ton of work as an open source. It takes more time to migrate. So here's what I got to say about PCF. So before joining Google, I also worked in the enterprise, right, where you got to run this stuff in production, right? Demos look all easy, but at some point you got to run this stuff in production. And what I've seen what people do with PCF is they'll take a big PCF install and start running PCF command line tools from their laptop and say, yes, this is it. I'm like, no, that is definitely not it. You're not going to be deploying to production from your laptop. I hope not. If you're like super serious, I hope not. And then when you add your second PCF cluster, maybe you're talking about another zone or another region or another data center, then this whole PCF push thing starts to make a little less sense because now you need a higher level tool. So at some point, even if you're using PCF, it will make sense to extract your CI/CD solution, whether you pick something like Spinnaker or Jenkins, but it's hardly a good idea just to have your CI/CD in the actual deploy target, right? You don't want the PCF control plane going down, and then you can't do any more CI/CD because the thing you're deploying to and the thing doing the deployments are in the same place. This would be bad, right? So at some point, you're going to step above and you're going to start to put a CI/CD thing at the top. Now, once you actually have CI/CD, Kubernetes becomes a deploy target. So in one case, it's going to be PCF push, and in the other case, it's going to be kubectl apply, right? So that's where you have to get to. So whether you wrap PCF push in your own bash script or some wrapper, there are a lot of these CI/CD systems now that do know how to treat Kubernetes as a high-level deploy target. You give it Kubernetes credentials, like Spinnaker, for example. You just say, hey, here's all my Kubernetes clusters. And then Spinnaker will just say, great, I'll wait for container images and I'll apply a deployment template to them. So it feels as simple as PCF push, or use something like KF, where then with KF, that becomes your interface into those clusters. So I think a lot of times we got to make sure that we're not looking at the happy path as like the ultimate production use case. Once you start having multiple clusters with multiple boundaries, that slight edge in UX starts to diminish once you start bringing in external registries, external CI/CD. And I think a lot of people find that maybe the lift isn't so big, right? Maybe it isn't so big. And then last thing there is you can now run batch jobs. You can now run jobs that have stateful, they need a whole volume. You can now take a lot of that Java stuff that you wrote 15 years ago and have a path into Kubernetes. You can run off-the-shelf third-party apps like Oracle, MongoDB, or Jira. You can run those in Kubernetes as first-class things. So what most people find is like, wow, I can actually now have more of a unified experience by leveraging Kubernetes versus saying, oh, I have to qualify an app to run well in Cloud Foundry, right? So that's the big trade-off here. So I think in aggregate, it's a net win. And we can always follow up on that one as well. All right. So the next question is I'm going to jump around. Oh, you have one?
Yeah, we actually have one from YouTube Live. So everyone watching on YouTube Live, we are moderating that. And so your questions are being pushed over. So the question we have from YouTube Live is, how does KCC treat resources during a kubectl apply? Are the resources destroyed, recreated, like how Terraform operates?
Yeah, this is a very great question, right? So the core idea here is promise theory, right? And I used to work at Puppet Labs, and the whole concept around this whole declarative resource model was you have a high level declarative API. Puppet uses a Puppet DSL, Chef uses a Ruby DSL, Terraform has HCL or JSON, and all of those front ends, you describe the resources that you want, and then you give it to some engine, and that engine is in charge of reconciling. So you mentioned Terraform here, right? And I'm going to assume most people know how Terraform works. But once you write your HCL, let's say you're describing a pub/sub topic, okay? So in Terraform, you would just say, hey, I want some pub/sub topic, and here's the attributes I want. And then you say, hey, Terraform, do your thing. And then Terraform has some control loops, aka plugins, that run and they check the resources, see if it exists. And if not, it recreates it. Or if it can, and this is always not a guarantee, if you use Terraform for a while, sometimes it can't always reconcile something. So sometimes it'll have to destroy and recreate it to get it back to a pristine state. The truth is, KCC in some cases is actually just using Terraform in the background. Haha, surprise. And the nice thing about that is the Google team actually generates a lot of the Terraform modules. So when we looked at this, we said, hey, why not use some of that logic? Now, here's the thing. We're not going to leak Terraform at you. We don't want you to have to learn Terraform. The whole point of this was you can actually use more of that Kubernetes model to simplify things. And since we're a cloud provider, that control plane doesn't have to be scattered across various laptops and people worrying about where the state lives. In this case, we can get closer to the Google implementation details. So in some cases, yes, we may use something like Terraform, and you're going to get very similar Terraform behavior. But the promise that we're making is one that's similar to Kubernetes itself. If you create the resource and you change the resource, we're going to try to make the resource behind the scenes reflect on that. And then there's going to be an option for every one of those resources that says, if the object, the Kubernetes manifest inside of the API server is deleted, should I go and clean up and destroy the resource? So that's going to be a flag you set to say, no, I don't want you to accidentally delete a resource just because someone made a mistake. But you can turn that on or off. But if you want to, yes, you're going to get something very similar to how Terraform operates and more closely to what Kubernetes does, right? Control loops, watch, and manage and reconcile state based on that Kubernetes config. So great question. And that is the goal, that we will have coverage across all of the resources. And one day, my guess is we'll just teach Terraform that instead of calling all of these Google APIs behind the scenes, it can then generate one of these resource objects, host it to an endpoint, and then just reconcile based on the status field, right? So this is going to make Puppet, Chef, Ansible, Terraform so much easier to integrate with GCP because they don't all have to go and figure out per language. Terraform is written in Go, Chef is written in Ruby, Ansible is written in Python. They all have to go and redo this work every single time. And then you start to see the lag in their ability to manage all the resources. I bet this is going to close the gap. All right. Wow, we're getting a lot of great questions here.
It looks like you have a follow-up question from what you just said. So someone asks, KCC sounds similar to AWS Service Operator. Is there any attempt to collaborate and bring some consistency between these solutions?
Yeah, so this is a good question. What we see now is the promise of Kubernetes taking off, right? The nice thing here is that we want to have a declarative model for as many resource types as we can. So this includes even the stuff inside of Amazon's world. And if you look at what's necessary there, especially when you start from Terraform or even CloudFormation, you can then generate a front end that looks like HCL, maybe without the for loops and iteration. And you can actually describe most of those. So in terms of collaboration, I think where we collaborate is making sure that their CRDs and the policy engines like OPA all work well so that we're all using the same tooling. And what you want to do is maybe Amazon, calls their fields something slightly different. Maybe they utilize the status field slightly different than Google does. But at the end of the day, the workflow is the same. kubectl apply a resource. It lands inside of something that looks like Kubernetes or actually Kubernetes. And then the status field has all the updates. So you never have to go behind the scenes to figure out the state of the resource, right? So that's the end goal. That's the high level. So we all collaborate at the layers underneath and the tooling. But above, we each all have the freedom to express our resources in the way that makes sense. And given the way Kubernetes does things, they all just start looking the same for the most part, right? So as long as we don't collide in namespaces where we're all using the same namespace to describe a VM, we want to see that partition like aws.com/virtual machine versus googlecloud.com/virtual machine. And I think we should be free to innovate at that level. So we are collaborating, but at the top, there may be other players, companies like crossplane.io, for example. They're making more generic resource types that will do things like just give me a VM, and then it will work out how to change, blow that up into a Kubernetes or a Google Cloud VM or AWS VM. So there'll be a meta layer above. You can kind of see that work already happening. But for that to work, we're going to need these lower level object types first. All right, so I'm going to go back to some of the pre-baked questions we got from customers, and then we'll jump back to some of the live stuff. So keep them coming. Hopefully this stuff is helpful for you all. It's enjoyable for me. High level talk about service mesh. Service mesh. This is the buzzword of the month. And the thing about service mesh that's kind of funny is that most people pretty much know everything they got to know about service mesh. The problem is most people are getting confused because maybe the marketing or how it's being re-implemented these days. So for those unfamiliar with the service mesh concept, we'll talk about one popular service mesh, Istio. So maybe I'll share my screen really quickly here. So the service mesh stuff, before I do that really quickly, what are their benefits and why you should stay away from them, okay? If you don't know what the trade-offs for a service mesh, you should just pause for a second, right? Because if you don't pause for a second, what's going to happen is you're going to look at something and you're going to be like, oh, I want TLS mutual auth. I want metrics. I want authorization in an agnostic way to my apps. And then you're going to install this in your cluster. You're going to be like, everybody's getting Istio. So people are going to wake up in the morning like that show I described. And you're going to install Istio. You're going to have this Envoy sidecar in front of all your apps. And you're going to notice the CPU utilization go up. So it's like, well, what happened to the CPU and the memory? It's like, oh yeah, we added sidecars to all 10,000 containers. It's so dope. And it's like, yeah, but we don't actually have enough CPU to actually do computation for the customers because you've made this trade-off for some of these conveniences by having this external proxy. Whether that trade-off is too high in terms of memory and CPU, you got to measure that stuff because it isn't free. And a lot of the things that people are trying to get out of a service mesh, for example, let's start with metrics. In the case of metrics, people are saying, I need visibility into what my app is doing. 15 years ago, you needed visibility into what your apps were doing. 20 years ago, you needed visibility into what your apps were doing. 20 years ago, there was a way to get visibility into what your apps were doing. You could have always used some library to track metrics and send them to a central place. You could have used something like Nginx or Apache, you guys remember those web servers, and put them in front of your application stack, and they could collect metrics and put them in a central place. You've always had the ability to do this kind of stuff. And in many cases, you're going to have to write some code. So a lot of people are interested in service mesh because they believe they're not going to have to write any code whatsoever. And the truth is, it's kind of half true. If you put a Envoy proxy in front of any application and you have some control plane to help you with the configuration, you definitely can get some basic metrics like how many clients are requesting, what paths are being requested. We call those black box metrics, right? The proxy is the thing that's taking the request. So of course it can generate metrics. And for a lot of people, that's better than nothing. So there's a lot of value that you can get from that. So that's a good use case. But then when you start to what real granular value metrics, you're going to have to go into your code and start to add more details about what's actually being invoked. that connection to the database, Envoy may or may not be in the data path for that. And that may be a blind spot. So eventually, you're going to have to start importing some library, whether it's a Prometheus solution that you go with. You're going to have to do something. The same is true for things like distributed tracing. At the black box side, yeah, you're going to get, hey, things went from this proxy to that proxy, but you're not going to have any context about what function is contributing the most time to the overall latency, right? And then you're going to be having these blind spots where you're going to find very difficult to troubleshoot. So again, you're going to have to bring in something like a Zipkin library or open telemetry library where you can start to add more details to each of these traces. So I would say there's a trade-off there. Eventually going to have to do some code work. When you should stay away from service mesh is when your platform already has something better, right? A lot of people think about service mesh as the only way to get things like traffic shaping. So I'm going to share my screen really quick. So what I mean by this is the whole point of these service meshes is because we want a certain set of features and functionality. You just don't install service mesh because someone else has one, right? That's not usually a good idea for anything in life, but especially for a service mesh because the trade-off may not be worth it. Now let's talk about something like Cloud Run, for example. I've been doing a lot with gRPC lately, and I have some examples online. But one thing I want to show you is like, what are we going for with the service mesh? Well, the couple of features most people want is the ability to manage traffic, right? So for most people, you want to have a smart network that can do a few things. So out of the box, when you deploy a container to Cloud Run, you get this URL, okay? Now, even though my application may not be binding itself to any TLS certificates, the edge gateway is, and I'm getting this kind of sidecar service mesh behavior for free, right? I'm adding security to an application that doesn't do it itself. So great, we get TLS for free. The next thing you want to do is have your service mesh be a little smart, right? So one thing you would like to do is say, hey, if I have two versions of my app, it would be nice to be able to manage traffic between these versions, right? So right now I have 100% traffic going to this particular version. And ideally, if I wanted to manage traffic, I should be able to do things here like change the percentages between these two, right? So a lot of times, if you have something like Envoy and a really great control plane, you can actually start to manage traffic in this way. Another thing that you can do at a high level once you have things like a service mesh is I can create these kind of like revision URLs. So if someone hit foobar inside of this URL, that traffic would then be split to a specific version of my application. And then the other thing that most people look for in a service mesh is things like identity and authorization. So in case of this particular platform, again, a lot of that stuff is built in where when I want to call between two different Cloud Run instances, I use something like IAM, which is my identity, and then I can give it permissions to call other endpoints inside of Cloud Run. So in this case, for a lot of people coming from like a serverless world, so this is Cloud Run or App Engine, a lot of that stuff that you want from a service mesh is already baked in. So you kind of have less of a need for bringing a tool like that into this particular world. So a lot of the functionality that I just showed you, a lot of people are after that in Kubernetes because Kubernetes doesn't have a native way of managing traffic or splitting traffic based on percentages. It doesn't have a native way of adding security to identity to each of these things in a way that you can use from service to service. So this is why we look at things like Istio to fill the gap. So hopefully that adds a bit of clarity about the service mesh thing. But remember, it's just a way to get a certain set of features that should be adding something to your applications. And the last thing I'm going to say here, you have to really think about how much logic you can put in the sidecar versus your application, right? That's a very important thing to think about here because a lot of people believe that they can do authorization, right? So for people that are a bit confused about authentication versus authorization, authentication is like who you are, right? This person is this GitHub user. This person is this Google user. That's who you are, but that doesn't say anything about what you can do. So now when we start to talk about what you can do, it can be as simple as you can call this particular path, right? Deposit balance or check balance on the banking API. And that could be based on your identity or what group you're in. The other thing you could do is say, well, can you even make this database query, right? And that may be something that has to be done in the app. So while you can definitely do some authorization stuff on the sidecar, it may not be granular enough to actually mimic what you need to do based on the roles that your users or developers have. That's where you're going to have to probably write some code again. So this is where I've been doing things like embedding OPA in my app to handle some of those authorization needs. And sometimes people feel like, well, if I'm going to have to do authorization in my app anyway, maybe I'm getting a little less, value from the sidecar, or it's just one of the layers. All right, so I'll stop there, but it's just lots to think about instead of just dropping a sidecar, believing that you can do everything there. It may help, but you just got to go through the process. All right, we got a lot of questions, so I'm going to speed up a little bit here for the sake of time. Wow, you guys really have some good questions. So let's just go through them. I'm going to jump through the chat here, and then maybe we'll stop to take some from the live. So here we go. Hey, Kelsey, related to above, do you worry about the increasing complexity, not only of K8s, for example, even GKE as a managed service? There's a lot of configuration options to be aware of in order to set a production-ready, secure system, while others can break your cluster. Yes, and I tweet about this all the time. For everyone out there trying to build their own platform as a service, their own app engine, their own Heroku, their own Cloud Run, you have a lot of moving pieces in that. When it comes to GKE, yes, we do a lot of QA of the various components. We try to pick a few baseline things for you and make sure they all integrate well. That's what people are paying for. But once you start adding a bunch of third-party stuff, you drop in Prometheus, you drop in Open Policy Agent, you drop in Istio, got Envoy, Fluentd, you start to have about 10, 12 different components. And when I step back from all of that, all you're trying to do is deploy some containers. And you start asking yourself, am I going too far? For a lot of people, you are probably going too far. You've probably driven off the deep end. Hopefully you can swim. And for a lot of people, what we're starting to see from our customer base is sometimes that complexity has to live somewhere. So let's not dance around that piece. You're going to have to live somewhere. So one thing you could do is say, I'm just going to use Stackdriver for tracing and for logging and for metrics, and not install Prometheus in my cluster. So a lot of our GKE customers, they actually don't install all of that stuff because we have things like binary authorization that runs as a managed service. They don't run a registry inside of their cluster. They use the Google container registry, which is fully managed backed by Google Cloud Storage. So in those cases, a lot of the complexity lives outside in different managed services over open APIs. So it gets a little bit harder on-prem where everyone wants this stuff kind of air-gapped and they want all of that stuff to run in the cluster. Then the lift is much bigger, okay? So I think a lot of customers that I'm seeing doing now, they're starting to use Cloud Run quite a bit more. So when you start to have like a simple web application or something that can live in the applicate or in a container, Cloud Run is a good first stop for a lot of people because what I just showed, a lot of the service mesh features are built in. A lot of the things about multi-region are built in. Load balancing and auto-scaling is built in. And the amount of things that you're responsible for, it's much lower. The contract is just different. So with Kubernetes, I think that complexity and flexibility comes at a cost. GKE to me is a good middle ground, but again, you can overdo it. A lot of people will install like 10, 20 third-party extensions inside of GKE that the GCP team doesn't know about. And if you go and auto upgrade your cluster and your third-party controllers aren't keeping pace with the changes in the Kubernetes API, they will break. And once they break, now you're on the hook for trying to figure out, hey, all 20 extensions that I'm using, I'm trying to upgrade to this new version of Kubernetes. And you're going to have to go knock on the doors of all of those maintainers to say, hey, your thing isn't compatible with where I want to be. And now you have to go do a lot of work. So there's a lot of trade-off in there. So I think here, what you have to do is you just got to look at it and be very deliberate about what extensions you bring. And this is nothing new, right? People have done this with databases. I've seen people take MySQL and add like 7,000 MySQL extensions, and they can never upgrade MySQL again, right? So this isn't new, but it's just something to pay attention to because Kubernetes allows you to do it. And to your point, GKE does not prevent you from leveraging the things you find in the open source world. So that's a gift and a curse. We don't block you from doing whatever you want to do. And the curse is we don't block you from doing whatever you want to do. What do you think is currently missing in the Kubernetes ecosystem? I'm going to give a very contentious answer. Nothing. There's no more we need to do in the Kubernetes space. We're done. Like Linux. Linux is also pretty much done. No more. Stop. I know people want Kubernetes to try to solve all of their problems. I remember when virtualization came out, we wanted it to solve all of our problems. It will never solve all your problems. I think Kubernetes is really good at what it does. It sits right there as this nice layer on top of infrastructure as a service, right? So Kubernetes already makes an assumption that there will be APIs to create machines and mount volumes and storage. It assumes that there's going to be an API that when the containers do come up that Kubernetes schedules, that it can attach them to load balancers. This is the layer that it plays well in. Now, what some people look at and say, oh, wow, wouldn't it be great if Kubernetes figured out how to manage multiple clusters? It's like, that doesn't make a lot of sense because it's the cluster. It can't also know about and manage other clusters. It's kind of out of scope. And to help you with that analogy, think about a single Linux VM. A single Linux container or machine knows about the local machine and its local resources. A Linux kernel has no way of dealing with other machines. It's the wrong layer to do it. So you bring in something like Kubernetes that sits on top that then knows how to deal with multiple things. So if we want to see some evolution in that space, I think it's going to have to sit above. Now, that control plane could run in a Kubernetes cluster, no doubt. But the system will be fundamentally different than what core Kubernetes does, right? It'll be a separate application that may take in Kubernetes-like configurations. It might, but it has nothing to do with Kubernetes. That system, if done correctly, should be able to run as a serverless application. It should be able to run on a VM. It should be able to run on a laptop because that's not what's being solved here. What's being solved is you want an API that says something like, hey, Kubernetes, or new thing, here is my wishes. I want this application to run across 2 regions, but not if that region costs more than X amount per hour. And then that new thing can look at that and say, okay, I know where all the clusters are. Let me go query those systems, take in a thing that looks like it has an embedded Kubernetes deployment object in it. I'll split that out. And then I'll talk to the Kubernetes clusters independently on the back end. And then I'll reconcile those things to make sure they're always true. And if you do that at that level, then you'll have the ability to say, oh, one of the Kubernetes clusters died. Well, this tool could create another one and deploy stuff there, as long as you make sure that you really decouple this logical layer from this logical layer, just like Kubernetes decouples its layer from the Linux layer. That's how this will have to work. And I think we've exhausted what we need to be doing at the Kubernetes layer. So I'm looking for more maturity and stability so that way we have less API breakage as we move forward. And now we can start to develop all those other layers, assuming the one below it is solid, right? So that's my opinion there. And the people that are doing that, I think are going to have a really good time. Okay. All right. So let's get some more here. Wow, lots of good questions. Which web services are best for Kubernetes? I think this is like, what apps should I be running in Kube? I'm just going to take that as what this question means. Honestly, if your app depends on POSIX APIs, if you're taking notes, write this one down. Like if you write this down, you're going to look like a genius tomorrow when you go in on Friday and just tell them, and pretend it's your idea too, so you get even more credit for it. If your app depends on POSIX semantics, meaning it expects a local file to be in the same spot at the same time, it expects that it can write to that file very fast, just like it's on a local machine. That's going to be a challenge because Kubernetes is going to assume that it can just reschedule your app somewhere else whenever it needs to. Now, there's things you can do to make sure that that app only stays on that single machine forever. But if you have a web app, I'll give you an example, WordPress. WordPress is going to be like, oh, look at the computer. Oh, is that a file system? Let me start dropping uploads into this spot on the disk. And then that machine dies. Kubernetes is going to say, no problem. I'll take your WordPress container and put it on this machine. WordPress is going to start up and say, oh, a machine. Where's the files? I don't see the files. That's cool. Maybe there were no files to begin with. Or it's going to have a database that says there were some files, but their files can't be found anymore. That's real bad. right? So the only thing you can do there is say, hey, Kubernetes, never move this thing from that machine. So that way you can't really do things like dynamic rescheduling. Auto scaling is a bit harder to do. So web apps that are a little bit better about being intentional with their data model, if you need storage, you got to be intentional. So things like NFS can help. Object stores are better, right? You're going to make a trade-off for reliability. If you have an object store, I can use something like Google Cloud Storage and say, hey, write this file to a central storage service that's going to always be available no matter what zone or region that I'm running in, right? That's going to give you the best fit for Kubernetes, right? So it's not about stateless only, because POSIX semantics aren't about just stateful and stateless. You just need to be intentional with your state. And if you're not, you're going to have some challenges with Kubernetes, okay? Do you think customize will supersede Helm? And if so, why? When you talk about customizing Helm, so for those that don't know, the first thing people do when they look at Kubernetes, they see YAML files, right? They're like, oh my God, look at all these YAML files. And no one in their right mind can ever understand all the possible options that go into a Kubernetes deployment object, right? You have to list the containers that you want. You can do things like define environment variables and so forth. There's a lot that goes into a Kubernetes config. So you write your first Kubernetes config, you say, wow, this feels good. Like I can read it, right? I know what's going to happen. If I take this config and give it to any new Kubernetes cluster, for the most part, I can assume that the application is going to run the same way every time. This is a big win over something like a bash script or maybe some config management tools. Now you write your 100th deployment YAML file. You're going to go on Twitter and you're going to be like, I hate YAML, right? And you're going to be like, oh, there has to be a better way than writing the same YAML over and over again. So the next thing you're going to do is probably do some template. You're going to try to put variables and if statements. You're going to bring in a whole programming language so you don't have to write YAML files. And then you're going to add unit tests, and you're going to add all of this stuff, and you're going to have a full development team because you didn't write YAML. And I get it. It's a good trade-off because reusability is a thing. But you're trading off a lot of complexity because you don't want to write YAML. Now, the analogy here is programming languages. If you had to write assembly by hand, you would also complain. It's too low level. But that's just how computers actually work. So we pick a language of our choice. We pick something like Node.js. We pick something like Golang, Ruby, Java. You pick it. But they're all responsible for generating something closer to assembly so we don't have to write it by hand. They give us something that fits our brains a little bit better. There is no one programming language, right? There are so many languages that some people prefer higher level languages that are specific to a particular task, making them worse at others, like JavaScript. Then you start to have general purpose programming languages like C and C++ that can do everything, but they have a little bit deeper syntax to learn. These are all of your options, and no one will ever agree that there will be only one way to generate machine code. So let's get back to the question. Will customize supersede Helm? The answer is it just doesn't matter. There are going to be some people that like Helm because of the programming model. They like Golang templates. They like the language. They like the fact that Helm has bundles. They like the command line tool, whatever. Maybe they like the logo better. But they'll learn Helm. They'll get comfortable with it. And they'll start to say, hey, Helm is the way I like to do things. This works great. Now, some people look at Helm and say, oh my goodness, this seems like more work than I signed up for. I need something a little more bare bones than this, right? So when you land in that particular spot, what you're looking for is something that you can just do a little bit of manipulation. So customize is slightly different. Customize is saying, hey, write just enough YAML files that you need. And then when you're processing those YAML files, so before you deploy them to Kubernetes, I like to think about this as data as code or infrastructure as data. And the concept there is I might start with 10 fields in my deployment object. So maybe I leave off the container. Maybe I leave off the replica, how many of those containers you want deployed. Maybe I even leave off the volumes, right? I leave all that stuff off. So now I have this very bare bones. So this is not a template. This is a subset. And then customize can come along and say, hey, If you pipe that baseline into my tool, I can apply changes real time. So then you might have little fragments. You might have a fragment that's like, attach this volume or attach this configuration file, right? So now what you can do is you can say, all right, if I have my CI/CD system, it may go and say, all right, customize, attach this container that I just built. So now you have this really nice workflow where you start with the bare bone, no if statements. You have something that actually works inside of a real Kubernetes cluster. And then you pipe it to customize and you keep a pending config to it. Why is this important? Well, Helm also swung in this direction as well. Helm used to try to say, look, give me my Helm bundles directly into your Kubernetes cluster. See, the problem with that is now Helm is running in God mode and it's generating Kubernetes configs on the fly because it still has to create those YAML files. They're just happening underneath the covers. The problem now is your interfaces, you have to understand Helm's dialect of the world. So you traded in YAML for Helm templating, and that's also going to suck at some point over time, trust me. There's nothing perfect here, but it could be the right workflow for you. Both tools, Helm and Customize, are moving into a world where they say, hey, I'm going to generate those YAML files no matter what, so that way you can check them in. You can version control. You can have preprocessors and validators and apply policy to them before you inject in your Kubernetes cluster. So I think both projects are learning from each other. Helm has a lot more functions and functionality. Customize to me is really great where you like modular config and you can let different tools modify that config, and Customize will help you do it the right way versus like loading in the whole YAML file and some specialized library that has special knowledge about Kubernetes configuration language. So that's the way I would choose those. So it's not one or the other. My guess is most people will use both. You'll start with Helm, generate those configs, and then use Customize to patch maybe the container instance, and then drop everything inside of a repo before you deploy it. That's how I think it's going to be a data pipeline. All right, we'll take 2 more questions from here, and then we'll go to a thing. Go ahead.
Okay. We have one from YouTube Live as well. So the question is, K8s can run stateful apps, but should you run stateful apps and databases on GK, or is there something else to consider to use?
This is the one that gets me into trouble the most.
Oh boy. Stay out of trouble, Kelsey.
There are people who, they may have changed their name to Kubernetes at this point. Some people are so in on Kubernetes for everything that they believe anything and everything should run in Kubernetes. So that's the extreme. So if you ask those people, they may say, yeah, of course, you can run everything in Kubernetes, everything, video games, everything in Kubernetes. I look at it this way. If you have no experience of managing a database, my answer would be no, because you personally don't know what you're doing, right? If I give you a chainsaw and you haven't as so much cut a banana, you're probably not going to know what to do with the chainsaw, right? You're going to cut your kitchen counters in half trying to use a chainsaw to cut a banana. It's like, it's not the right tool for the job. The specific reason here is this. If you have MySQL, most people take MySQL and they get 2 virtual machines, or maybe they'll get 2 bare metal machines, and they'll install MySQL on it, and they'll leave it alone for years. They will never touch it, right? They get it working, and they leave it alone. If I say, what if I walked around and I start pulling the power on those machines and plugging them back up again? They're like, oh, no, don't do that. We'll be down for too long. We can't take that kind of risk. So they have no operational experience of the database going up and down and moving around. They've just never done that before. So they figure if I just rub like some Kubernetes sauce on it, okay, just like you just take your problem and you just like rub a little bit of kube on it, it's going to turn it into a distributed database system. I'm like, no, it's not actually. It's just going to be the thing that you have already and all of its problems in Kubernetes, and Kubernetes is probably going to highlight those problems more often than you're ready for. So if you just blindly take your MySQL database and just use a standard deployment, Kubernetes will run it, and you're going to be like, oh, look it, I got MySQL in Kubernetes, and going to go on Twitter and going to show everybody. And then you're going to restart one of the machines, and Kubernetes is going to move it, and you're like, oh, what about my data? And then you're going to say, oh, I can do a stateful set, right? So now you take a stateful set, Kubernetes is attaching and detaching volumes. You're like, yeah, see, now you can do it. So now Kubernetes is moving around MySQL twice a day. And you're like, whoa, 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 whoa. I'm seeing so many outages because of Kubernetes. Like, no, you're not. You told Kubernetes that it was free to move around MySQL when it saw fit, as long as it brought it back up with the same storage and the same container. But you have another problem. Guess what? Every time that container restarts, it's going to get a new IP address. Aha! Most MySQL clients can't deal with that. So now your clients stop working. And then you go and say, all right, I'm going to find a tool that will help me have a stable IP address. So what you're doing at this point is you're kind of working against the fact that MySQL is not ready to live in a dynamic environment. It is not. There are some open source projects that are almost as big as Kubernetes itself. Vitesse comes to mind. So what Vitesse tries to do is all of the things you need to have MySQL behave well in such a hostile computing environment. Now, there's other databases like CockroachDB, which is a little bit closer to Google Cloud Spanner. CockroachDB was designed to run in something like Kubernetes. It was designed. It knows that things will move around. It knows how to fix itself. It knows how to replicate its own data just in case one of the nodes goes away. It just does a lot of work to meet Kubernetes halfway. So when you're talking about CockroachDB, even MongoDB to an extent, some of the key value stores like Console and etcd, they are much better suited to deal with this environment because they were designed to deal with that. MySQL, Postgres were not. So can you do it? The answer is yes. Should you do it? Depends. Like, how much pain can you tolerate? And are you willing to fill the gaps? Because there will be some. So that's my answer there. You can do it, but don't expect just installing something in Kubernetes is going to turn it into Cloud SQL, because it's not. Good question. I'm a fresher in Kubernetes. How do we get to know that there are configurations that we have to add to a domain? What is it to work perfectly without any issues? So how do I use Kubernetes perfectly? Well, I'm new to Kubernetes. You're not going to learn Kubernetes perfectly. I think what you can do is start looking at some of the practices that people are doing. You notice I didn't say best practices. At this point, everyone's just practicing. Things like pod disruption budgets. We have some guidance on the Google Cloud about here's how you help protect your workloads from things like automatic upgrades, things you can do to make sure that automatic upgrades run smooth. And they're going to mention a lot of things that most people don't get to on day one. Pod disruption budget, so that way we don't scale down too fast. Making sure that you use more than one replica, so that way you're thinking to survive HA. How to think about some of these things, and there are going to be different types of config objects that you can pair with your deployment object. So if you're new to Kubernetes, most people are used to things like deployment, service, ingress. But really what you need is things like config maps, pod disruption budgets, think about things like using resources effectively. Be patient, right? Read some of our documentation about what you do on day 2 and day 3. Be patient. The nice thing about Kubernetes, as you learn and you start to update those configurations, that learning sticks with the platform, right? It's not something you're just doing by hand and ad hoc. They're going to be permanent fixes. And now you start to build up a catalog of like, oh, these are the configs my company should be using, so we get what we want out of Kubernetes. That's the thing I like about Kubernetes. It grows with you, and you can look at your config and see how you've grown. That, to me, is the beauty of this whole Kubernetes API model. I'm going to go back to the email really quickly because the people that did take time to submit questions, I'm going to jump in real quick. Let's see here. Oh, I most like to hear what he thinks we should be preparing for next in the Kubernetes world. We touched on this a little bit earlier. I really think since Kubernetes is getting way more solid and mature, we should really start looking at our application layer and start asking ourselves, okay, if we're doing a good job at the infrastructure layer, what can my app do to help? Adding help checks is a very obvious place to start. And people are like, why is help check so important? Well, it's important because Kubernetes can leverage those help checks to do smart things like not add your app to a load balancer until it's actually ready. And everyone's like, oh, yeah, that's common sense. But you know what? A lot of companies aren't doing it. So add real health checks. And a real health check isn't just returning 200 because I asked you, are you healthy? You're like, yeah, I'm healthy. No, you actually need to check stuff. Can you connect to your database? Can you connect to your file system? Can you connect to your dependencies? And the answer is false. Then you got to be careful about this, but you can actually say, hey, Kubernetes, I'm just not ready right now. So don't send me any traffic, right? That's a big win. The other one is thinking about authorization. Again, open policy agent, getting better at having more granular security than just network reachability. So a lot of companies out there are using all of this cloud native technology, and they're just simply hiding behind the firewall. So once you get behind the firewall, everything blows up, right? And then you're on the news in the bad way, right? You're on the news because you had some breach or some weird thing happened. There was a case where someone, I won't mention any names here, but someone logged into their bank account and looked up at the URL and saw something like ID 123. And they said, hey, I'm logged in. What if I change that to like 1234? What would happen? And there they are staring at someone else's bank information. See, that's terrible. See, that's what happens when you try to hide behind the firewall, because the app in this case, the person's authenticated. I don't know if it's the right user, but they're definitely authenticated. And they're asking for something that is not theirs. But since you're not doing authorization at the app level, that became a blind spot to the infrastructure. So you allowed it to pass through. You got to go and do that in the app, because you can't just do that along the edges, right? So this is the stuff that honestly is not what you do after Kubernetes, what you should be doing anyway. But here's the thing. If you got Kubernetes taken care of, the goal isn't try to go and put everything in the world in Kubernetes. The goal now is to start to try to get your app in shape so that it has the same resiliency that Kubernetes is bringing to the table. That would be my advice. Just go through that app tier and start adding better logs. If you got logs today, think about structured logs. Think about logs that have context of the request baked into the log, so your team doesn't have to grep. All these people running grep all day trying to find the damn logs that goes to the request. If you just put the request ID as a field in the structured log, you can just say, hey, Stackdriver, show me the logs that are paired to this particular request. And it's like, oh, we don't have to grep anymore. You can actually do that in 2020. That would be my recommendation. Start using some of the things that have came out in the last decade, and life gets a lot better, I promise. So there's a lot of other projects outside of Kube. Start leveraging those projects, because the whole world won't live in Kubernetes, but you can actually start to take some of the ideas from Kubernetes and applying them in other places. I think that's going to be dope. I keep hearing about putting all of our apps in their own namespace. And I'm kind of like, what does that actually do? Is that useful? Okay, so this question is kind of this kind of day two thing that people look at when they're looking at Kube. I have this Kubernetes cluster, and I said kube supply. I went on the internet and I just found stuff, and I was just like, hey, Kubernetes, run the stuff I found on the internet. And it's all in the default namespace, right? So when you say kubectl list, you see all this stuff that you downloaded from the internet plus your production stuff. And someone's like, hey, maybe we should separate these things. So now we got to talk about layers of separation. If you're talking about separating them on different servers, then namespaces do not help you at all, right? Namespaces is a Kubernetes construct, right? It's for the Kubernetes API. So when I say something like, Kubernetes, show me all the containers running in my cluster, well, I'm only going to show you the ones that you have access to at the API level. So if there's an app in a different namespace and you don't have permissions and you didn't ask for it, well, I'm not going to show you those. So that's a logical partition. But the truth is, no matter if you break these things into namespaces or not, there's a potential they're going to land on the same servers. So from a hardware perspective, they may just land on the same servers anyway. So this is not going to be hardware level isolation here. So what's the value though? There is value in namespaces. I don't want to make it seem like there's no value in namespaces. Namespaces are great because if I only had a single cluster and I wanted to give my developers their own sandbox to play in, the analogy here is thinking about one Git repository, right? Having the ability to create branches allows different teams to work on code at different points in time and put it all in the same repository. So I like to think about namespace as kind of like a branch in some ways. That's one way to think about it. So developer A, instead of giving them their whole cluster, I can create a namespace and say, hey, Kubernetes, don't allow them to deploy at a high level more than 10 containers into that namespace, or they can't use as much CPU or memory at this allotment. Then it starts to work a lot like GCP projects, right? There's only one GCP, but we give you logical boundaries in the form of projects, right? And then once you have a project, then IAM can scope activities to the project level. And the same is true of Kubernetes. We can start scoping things along this nice logical boundary. Sweet. The other thing that it does is like in production, when there's only one set of apps, some people do like to have their own namespace to try to protect things, right? Like this namespace is going to have some containers and maybe some config maps that we don't want other people seeing or accessing, because that stuff lives in the Kubernetes API and never lands on a machine until you tell it to. So some people want to partition that, and maybe you don't want mistakes where people are deleting the wrong app. They should only be focused on their app. So one way of doing this, instead of having very granular control at the app level, you say, hey, look, team, I'm going to give you your namespace. That's for your app. Do whatever you want. I'll give another team a namespace for their app. They can do whatever they want. And then you have to be a little bit more explicit when you start to communicate now, right? So now you would say, I want to talk to an app in this other namespace. And that's a little bit more explicit than I just want to talk to an app that's next to me. So it can provide some value. It's a soft limitation in terms of hardware. And in terms of the Kubernetes API, it's a good way of, giving people logical namespaces to do their work without trumping or stepping on each other, right? You can have two apps named Foo, but they're in different namespaces. So that can be pretty cool. And namespaces also give you a way to reflect environments. This is my QA namespace. This is my production namespace, same resources. And I may give lower priority to the QA namespace to make sure that production is healthy. So many things you can do with it, but just make sure you know that it's not a hard multi-tenant solution. All right, so I got one more from, I think that's it from the email for now. And we're just going to go back through, and I'll pause for a second, Ashley, to see if there's any more from live, or should I just keep going with the chat?
It looks like you could just keep going from the chat. I know we only have 9 minutes left. So I do actually have a question for you from myself. So Kelsey, we have people all over the grid on here. Some people are GCP lovers and some people are GCP non-believers. What would you say to those who are GKE non-believers to get them to, feel the GCP love, want to try it out?
Honestly, I kind of have a lot of empathy for that, right? Because before joining Google, I did pay for GKE or before GCP itself. And I also used Amazon before, right? I've been at companies where everything was on Amazon. And as an engineer, you don't really care too much unless there's something you can't do, or if I'm spending too much time, because you're voting with your dollars every month when you pick a cloud provider, right? So if all you need is virtual machines, you know what, man? It's such a commodity. I'm not going to sit here and lie to you and be like, Google has the best commodity virtual machines in the world. I think we have a great API. I like how fast they spin up. I like what we've done with G-Cloud and integration there. But look, it's a VM. You can get a VM from anywhere. So I think for people that are like, why am I going to waste my time with GCP? So a lot of companies that were on Amazon, so I'll talk specifically to people, especially the digital natives out there who have the skills. They know what it takes to run this stuff themselves. They look at this and say, while we could run Kubernetes ourselves on a bunch of VMs, we're electing not to, and we'll rather have and work with the Google engineering team. So one big difference that I've seen since joining Google 4.5 years ago is the fact that we allow people to work directly with our engineers a lot, maybe more than we should probably do. And a lot of the stuff that people want to see in Kube, even the upstream stuff, so not just our commercial offering, is that we push stuff in the open source to make our commercial offerings better. And I think until Google really showed up, we didn't see a lot of cloud provider open source synergy, right? It was like, oh, we'll run your stuff for you, but it wasn't really based on open source. GKE shows up, you get Kubernetes. Google just has this consistency for more than 10 years now, whether it's Google Chrome or Android or Go programming language. We have proven that we can work well with open protocols and APIs as first-class citizens. So what that means is, when we think about Kubernetes, we hold true to making sure that we're not giving you the enterprise Kubernetes with some crazy set of APIs that don't work anywhere else. We're giving you the same things that the competition would have access to, except for we go all in. We change how GCE works. So VMs can now mount way more volumes than they could before because Kubernetes came around. We've changed the way VPCs worked. That took multiple years to make sure that the pod IPs, your container IPs, are first-class citizens. You don't need routes in GCP because of that. So we go so deep in our belief in open source that we changed our core platform to reflect that. So for a lot of people that are like, hey, I like open source, number one, I'm a contributor, and it's not about just free. A lot of the open source stuff has proven to innovate faster than the proprietary stuff. So a lot of people see it's like when you come to Google and you say, hey, what's your security policy engine? And we tell you it's based on OPA and Rego. Well, that's where a lot of the innovation is happening right now in the security space around policy management. That's how GCP works. When you say, how should I run a container? We say it's Kubernetes. That's just how, and that's where a lot of the innovation is happening. So for a lot of people, where open source is their sweet spot, and they want the conveniences of a managed services with the innovation at the pace of open source and kind of that reliability, that's when they come over to Google. And the last thing I'll say here is this. When I was looking and learning about distributed systems, so this is before joining Google, maybe about 12, 13 years ago, I started reading the various white papers by Google, big data, MapReduce white paper. You're reading about Borg. You're reading about all of these Google concepts, whether it's around tracing. And fast forward to where we are now, maybe even starting about 5 years ago, a lot of those white papers have turned into open source projects. We're the very start of the foundation, CNCF. So a lot of the ideas on how we should be doing this stuff, a lot of those ideas were born at Google, not only Google. To be very clear, there are a lot of people outside of Google doing great work. Red Hat, CoreOS, Docker, the list goes on and on, Twitter, so many more. But what we're seeing, though, is that we've taken a lot of those things and our cloud and our commercial offerings, they sit at the foundation. So for people that are non-believers, I encourage you to just go over there, click the button, validate it for yourself, put your hands on it, and then you start to say, okay, I see what's going on. And this is why we had some customers who, what I described was their core, saw GCP as a no-brainer because that's the world they wanted to live in.
Awesome. Thank you so much. I know we only have 4 minutes left, so I think that's a good question to stop on so we can, tell people what's coming up next for next week. But Kelsey, thank you so much for joining us today. I know our customers as well as GCP fans were super excited to have you today, and I know our team was as well. So thank you so much for being a part of the OK Google team and being our special edition of OK Kelsey Tell Me How.
Awesome. Thanks for having me.
Thank you. Everybody, so what I just posted on the side was our check-in survey. So on the survey, we'll have you guys check in as well as tell us how we did and leave comments for what you guys would like to see next, as well as if anybody would like to continue the conversation, please let us know and we can have someone reach out to you and continue to talk to you guys about Kubernetes. And then for what's coming up next week, I posted in the chat on the side our landing page for our OK Google Tell Me How series. And so on that landing page, you can start signing up for the next upcoming weeks. So next week, like I said, we'll have Mike from Chronicle talk about cybersecurity best practices. And then the week after that, we'll have our very own Alan Ranciato talk about optimizing costs in Google Cloud. Awesome. Well, everyone, thank you so much for attending. Like I said, if you'd like to continue the conversation with anybody on the OK Google team, here is all of our information at the bottom. Please feel free to email us, ask us any questions, and give us your feedback. We'd love to hear from you, and we'd love to incorporate things that you guys want to see in our next and upcoming webinars. So everyone, thank you so much.